Hello, viewers. Answering Jamb questions can be very difficult and tricky, especially if you're not familiar with the rudiment of chemistry. In this series, I'll be taking you through Jamb past question 2018. I am Adelabu Sunday, your chemistry online tutor. So let's take a look at some of the questions. Jamb 2018. Question number 1 says, the periodic classification of the element is an arrangement of the elements in order of their A. Atomic weight, B. Isotopic weight, C. Molecular weight, D. Atomic number. So looking at the question, we should ask ourselves, where is this question coming from? That is from the periodic table. And when you look at the elements in the periodic table, they are arranged according to their atomic number. That's why when you look at, let's just take a rundown of group 1 element, where we have hydrogen, lithium, sodium, potassium. Now, looking at the series now, you discover that hydrogen is 1, the next one is 3, that is lithium, while the next one is 11, the next one is 17, that is using the atomic number. And when you look at period 3, for example, where you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So look at it from 11 to 12, 13, 14, 15, 16, 17. That is in order of their what? In order of their atomic number. That's what they use in arranging the elements in the periodic table. So the right answer is atomic number. I hope you get that. Let's look at number 2. If 1 liter of 2.2 mole sulfuric acid is poured into a bucket containing 10 liters of water and the resulting solution mix thoroughly, the resulting sulfuric acid concentration will be. So what they're demanding from us now is for us to calculate the concentration of the resulting sulfuric acid. A 2.2 mole, B 1.1 mole, C 0.2 mole, and D 0.11 mole. Now looking at the question now, the formula we are going to use in solving that is C1 V1 equals C2 V2. That is concentration formula. Now when you look at it, our C1 is 2.2 mole, while our V1 is 1 liter, our C2 is what we are looking for, while our V2 is 10 liter. Now, using the formula C1 V1 equals C2 V2, so we now try to make our C2 the solution of the formula. So from there, we divide both sides by V2. From there, we now have our C2 equals C1 V1 over V2. So substituting the value, we now have 2.2 times 1 all over 10. So when you solve, you now discover that the answer is 0.22 mole. That is the molar concentration. So the answer is 0.22 molar concentration. Question number 3 is a diagram of which I won't be able to lay my hands on it using this video. Let's look at question number 4. A correct electrochemical series can be obtained from potassium, that is K, Na, Ca, Al, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold by interchanging. So what do you need to interchange in those ones I've listed? That is to give you correct activity series. That is potassium, sodium, calcium, aluminum, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. A. Aluminium and magnesium. B. Zinc and iron. C. Zinc and lead. D. Lead and hydrogen. So if actually you know the electrochemical series very well, you discover that magnesium comes before aluminium. So exchanging aluminium and magnesium will give you the right series. So the answer is A. Now let's look at number 5. A basic postulate of the kinetic theory of gases is that the molecule of a gas move in straight lines between collisions. This implies that A. Collisions are perfectly elastic. B. Force of repulsion exists. C. Force of repulsion and attraction are in equilibrium. D. Collisions are inelastic. So just look at it. A basic postulate of the kinetic theory of gases is that the molecule of a gas move in a straight line between collisions. This implies that the collisions are perfectly elastic. That is the correct answer. That is A. Now let's take our question number 6. In which of the following is solubility of gas substance dependent? They are asking us In which of the following is solubility of a gas substance dependent? 1. Is it the nature of the solvent? 2. Is it the nature of the solute? 3. Temperature. And 4. Pressure. Now, option A, they say 1, 2, 3, and 4. B, 1 and 2 only. C, 2 only. D, 1, 3, and 4 only. Let's ask ourselves this question. The solubility of a gas, does it depend on the nature of the solvent? Yes, it depends. Why the second one, nature of the solute? Gas does not depend on nature of the solute. Gas depend on the temperature, and gas also depend on the what? On the pressure. So meaning the right answer is 1, 3, and 4. So the correct answer is D. That is option D, 1, 3, and 4. Let's look at question number 7. Which of the following statement is correct about the periodic table? Which of the following statement is correct about the periodic table? Meaning from option A to D, only one is correct. A, elements in the same period have the same number of valency electrons. B, the valency electron of an element in the same period increase progressively across the period. Elements in the same group, that is option C, elements in the same group have the same number of electron share. D, the non-metallic property of an element tend to decrease across each period. Let's look at the option. Elements in the same period have the same number of valency electrons. That is wrong. Elements in the same period does not have the same number of valency electrons. Look at period 3, for example. Sodium, the valency is 1. Still on the same period, we have magnesium, the valency is 2. Still on the same period, we have aluminium, the valency is 3. And when you go on, it increases from 1, 2, 3, 4, 5, 6, 7, 8. That's how we have group 1, group 2. So option B, the valency electron of an element in the same period increase progressively across the period. Yes, that is correct. When you look at each of the elements in a period, the valency increases from 1 to 2 to 3 to 4 to 5, 6, 7, and 8, or 0 as we do call it. So meaning that the valency electron of an element in the same period increase progressively across the period. Option C, let's see how it is wrong. Elements in the same group have the same number of electron share. No. Elements in the same group don't have the same number of electron share. Like group 1 now, the share there is 1. That is why it is like the first period, the number of share there is 1. That is why it is period 1. The second period, the number of shell is 2. The third period, the number of shell is 3. As the period, as we have period 1, mean the number of shell is 1. Period 2, the number of shell is 2. So we use the number of shell to tell the period. So element in the same group does not have the same number of electron share. Option D, the non-metallic property of an element tend to decrease across each period. That is wrong. So the non-metallic property of an element tend to increase across the period. Look at it now. You have metal from group 1 to 3, and go from 3 to 4, you have the metalloid and you have the non-metal. So meaning the metallic property is decreasing while the non-metallic property is increasing. So it's the metallic property that decreases while the non-metallic property increases. So the correct answer is the valence electron of an element in the same period increases progressively across the period. Let's look at number 8. The boiling point of fat and aqueous caustic soda is referred to as A, hydrolysis, B, esterification, C, acidification, and D, saponification. So the right answer there is saponification. That is when you boil fat and aqueous caustic soda, it is referred as saponification. That is how we produce soap in the lab. Question number 9. Which of the following pairs of substance will react further with oxygen? Which of the following pairs of the substance will react further with oxygen to form a higher oxide? A, carbon 4 oxide and water. B, nitrogen 2 oxide and water. C, carbon 2 oxide and carbon 4 oxide. D, sulfur 4 oxide and nitrogen 2 oxide. So looking at it, CO2, for example, will not react further with oxygen. Water too will not react. So option B as well, water there will not react, but NO2 will react. Going to option C, CO will react with oxygen, but CO2 will not react with oxygen. But let's look at option D. CO2 will react with oxygen to give CO3. That is from sulfur 4 oxide to sulfur 6 oxide. While that of NO, that is nitrogen 2 oxide, will react with oxygen to give nitrogen 4 oxide. So the right answer is option D, that is SO2 and NO. Now looking at question number 10, in the preparation of oxygen by heating potassium trioxochlorate 5 in the presence of manganese 4 oxide, only moderate heat is needed because the catalyst acts by A. Lowering the pressure of the reaction, B. Increasing the surface area of the reaction, C. Increasing the rate of the reaction, D. Lowering the energy barrier of the reaction. Looking at the question, they want to know what is the function of catalyst, and the function of a catalyst is lowering the energy barrier of the reaction. Then it makes the pathway to be very short, or to be short, as the case may be. So the right answer is that the catalyst, that is catalyst manganese 4 oxide, lower the energy barrier of the reaction. Number 11. This is one of the questions that many people gave different answer to it. Reason be that they may not understand some of the concept or the way the question is being asked. Let's take question number 11 now. Methanoic acid mixes water in all proportion has about the same boiling point as water. Which of the following method will you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A. Fractional distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. And D. Neutralization with sodium hydroxide followed by filtration. Now, looking at the question there, the question says methanoic acid mixed with water in all proportion and has about the same boiling point as water. Which of the following method will you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? What you want to get here is water. Now, if somebody say fractional distillation, something that has almost about the same boiling point, you can't use fractional distillation. It's when they are slightly different in their boiling point. That is where you use fractional distillation. And option B there, fractional filtration followed by distillation. By the time you filter, you get the sand as the residue. So the distill now is the methanoic acid with the water. Since it has almost about the same boiling point, distillation will not work here. Now let's look at option C and D. Neutralization with sodium hydroxide. Option D is also neutralization with sodium hydroxide. But what follows after neutralize it? Because when you neutralize the acid with sodium hydroxide, it will give you a salt and water. And you should ask yourself, what type of salt? Is it a salt that is soluble or insoluble? Automatically, the salt we have here is what? The case of the salt we have here is soluble salt. Now, you have soluble salt in a water. How do you separate a soluble salt? After you've neutralized it, that is option D now, neutralization with sodium hydroxide, neutralization with sodium hydroxide. But what now, the difference between it is that one is distillation, while one is filtration. Now, if you decide to distill, yes, it will be correct because the salt is soluble in water. By the time you distill it, you get your pure water because you get your pure water. But in case of filtration, if you filter, you have the residue, which is the sand. But come to think of the salt that is soluble in water, how do you now get it? So the right answer is neutralization with sodium hydroxide followed by distillation. So that is the correct answer. Now let's look at question number 12. A quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium will be liberated from its salt by the same quantity of electricity? You know, the mass number of aluminium is 27 grams, while that of silver is 108. Option A, 2.7 gram, B, 1.2 gram, C, 0.9 gram, and D, 0.3 gram. You know, if you look at the option given to us, you need to be very technical in this case, and you need to know where the question is coming from. The question is coming from Faraday's second law of electrolysis. Now, what does the law state? The law states that when the same quantity of electricity is passed through different electrolytes, here now, the different electrolytes we're having here is aluminium and that of silver. Through different electrolytes, the relative amount in moles of the elements deposited are inversely proportional to the charge on the ion of the respective element. Now, we are given 3.6 grams of silver. And you know that silver, to have a silver ion, there will be loss of 1 electron. So that means now 108 grams of silver will give you 1 Faraday. That is 108 will give you what? 1 Faraday. Now, they are giving us 3.6 grams, and 1 Faraday is 96,500. So meaning 108 will give us 1 Faraday. That is 108 will give us 960. That is 96,500. The mass of silver we are given in the question is 3.6. Now, meaning 3.6 gram will give us X. So when you equate it, you cross multiply. You now have 3.6 times 96,500 divided by 108. By the time you solve it, you have a number there, which is 3,216.66667. From there, now we've gotten the quantity of electricity deposited. It's now left for us now to go and equate it to know what mass of aluminium we deposited. When you look at aluminium, for you to get aluminium ion, there will be loss of 3 electrons. That means 27 grams of aluminium will give you 3 Faraday. So meaning you now have 27 grams equal 3 times 96,500. So S gram now will now give you the quantity of electricity we have from that of silver, which is 3,216.6667. So from there you equate and solve. You now have your S gram equal to 27 times 3,216.667 divided by 3 times 96,500. So when you solve, you discover that you have 0.3 gram. That is the correct answer. The answer is D. So be very careful how you equate. You should know the number of charges that will be deposited or liberated. If not, you surely miss it. Let's look at the last question in this series. A suitable reagent for the laboratory preparation of nitrogen are a suitable reagent for the laboratory preparation of nitrogen are A. Sodium dioxynitrate 3 and ammonium chloride. B. Sodium trioxynitrate 5 and ammonium chloride. C. Sodium chloride and ammonium trioxynitrate 5. D. Sodium chloride and ammonium dioxynitrate 3. So looking at the question, if you're familiar with your SS2 topic, that is second time, you discover that the right answer there under nitrogen and its compound. The right way to prepare nitrogen in the lab is using sodium dioxynitrate 3 and ammonium chloride. See you in my next class where I'll be explaining from number 14 downward. Thank you for staying through.